Unit 8, Targets 1 and 2 homework, page 306, number 31. Your friend says it's impossible for an angle bisector of a triangle to be the same line as the perpendicular bisector of the opposite side. Is your friend correct? Explain your reasoning. So let's see what type of triangles I can draw here. If I take a triangle that looks like this and I draw a perpendicular bisector, it doesn't go through it doesn't go through an angle. So that one wouldn't work. If I drew a perpendicular bisector for this side, it's closer. And so the question is there a way to draw a triangle such that we can make this work? Well, we talked about isosceles triangles, and so let's look at an isosceles triangle. If I take the vertex angle of an isosceles triangle, which means it's the angle that's not congruent. The base angles are congruent because the legs opposite them are congruent. So this is my isosceles triangle. If I draw an angle bisector for that one, for the vertex angle, sorry, and I'll move that over. So there's my angle bisector. If I just look at the diagram, I have enough information in the diagram to show that the two triangles on the left and the right are congruent because of angle side angle. So if the two triangles are congruent, that means that their corresponding parts are congruent. So the small side of the left triangle is going to be congruent to the small side of the right triangle. And this angle at the bottom is going to be congruent to this angle at the bottom. And so since I have a linear pair of those congruent angles, those are perpendicular. So in this case, the angle bisector is a perpendicular bisector. So that will work if you draw it through the vertex angle of an isosceles triangle.